Hi all, my name is David Blowbaum. I'm one of the co-owners of Summit Prep, and what we're going to talk about today is some tricks that we can use for the reading section. So what a lot of students don't know is that on the second and fourth passages on the reading section of the ACT, these are science passages. So the fourth passage, which we're going to go over, is the natural science. Fourth passage is always the natural science. And the second passage is always the social science. So because they're science passages, they're always factually correct. So just knowing that things that are factual are usually reasonable, we can use reasoning to very often get the answers correct. So it doesn't mean that you should not read the passage, but it means that you should just, realize that you can reason answers out. So if you're struggling with an answer choice, you can pick what's reasonable. Also, if you're running out of time and you didn't get as much time to read the passage, or you use the first last trick and didn't read the passage fully, then you can still get a lot of answers right. And the first last trick, what I mentioned is, which we go over with students, is you read the intro, you read the first sentences of each body paragraph, and then you read the conclusion. And just doing that will give students a very good understanding both of the main idea and of the structure of the passage. And that's really all you need to be able to go on to the questions, is to know the main idea and structure. So I'm just going to do a hypothetical and say that a student wouldn't have any time. They're really running low on time and they know that they can't take any time to read the passage. What they should still absolutely do is read this intro. So we're going to show just this, actually not even just this intro, it's just the title of the passage. So what we're going to go over is how just knowing this title and using reasoning, we can get most of the questions correct. All right. This passage is adapted from the article Not Dead Yet. A dying star is caught flaring briefly back to life by Charles Liu. So let's go on to the first question. The passage indicates the one difference between a sun-like star and a dying star is that a sun-like star. So the difference between a sun-like star and a dying star is that a sun-like star has more fuel for nuclear fusion. Yeah, I would assume that a sun-like star would have more fuel than a dying one, because the dying star is probably running out of fuel, right? So that seems really reasonable. Has a larger planetary nebula. Maybe a sun-like star has a larger planetary nebula. Sun-like star is more often studied with a photometer. Yeah, maybe a sun-like star is. Sun-like star has more dramatic fluctuations in brightness. Yeah, maybe. But I can be really, really certain, just by reasoning, just by what seems reasonable, that a sun-like star is going to have more fuel for nuclear fusion. So we could just guess that it's A, and the answer actually is A. The main purpose of the first paragraph is to describe how some stars flicker back to stellar life before becoming white dwarfs. So remember, this title is Not Dead Yet. A dying star is caught flaring briefly back to life. So dying star is caught flaring briefly back to life. So one of our strategies, in addition to reasoning, is to default to the main idea. So if you have no idea on an answer choice, you just want to pick the answer that's closest to the main idea, and usually you're going to get it right. So this sounds really good. Describe how some stars flicker back to stellar life. So I'm assuming we don't have time to read the first paragraph again, or even skim it. But if I didn't, this sounds really good. Use FG Sagittae as an example of a star currently heading toward the white dwarf phase. Well, it's not really hitting the main idea as well as F. Explain the dying process of stars from the red giant phase through the white dwarf phase. Sounds pretty good, because we know that flickering back to life briefly, it's still about the overall dying process of the star. Even if it's interrupted. Sounds pretty good, but not quite as good as F. Contrast the longevity of a red giant with that of a white dwarf. Well, it's not about the longevity of these stars. It's about them, flickering briefly back to life and then dying out. It's not about their longevity. So I would have picked F if all I had read was the title and had reasoned it out. It's actually H, because this was just an intro to the passage about the dying process of a star. So I would have gotten this question wrong. So right now, 50% right, just reasoning. So let's go on to the next one. The author quotes a Dylan Thomas poem in lines 15 to 16, mainly to introduce the passage's point that. So some key words here is to introduce the passage's point that. So it's some point of the whole passage. So this really should stay on the main idea then. So let's just assume we can't even go back to lines 15 to 16, and we're going to try and reason it out, knowing that we're going to stay on the main idea. Astronomers often feel nostalgic about the stars they have studied. Doesn't fit with the main idea as far as we understand it at all. A dying star is sometimes a danger to the stellar matter around it. Okay, so we have this good term here, or these good words here, dying star. We know the main idea of this passage is about a dying star, but there was nothing about it like being a danger to stellar matter around it, and it's unclear how stellar matter would be put in danger. So I'm going to eliminate that. Scientists often refer to white dwarfs as being in a gentle stage of a star's life. I would say no. It's not about a gentle stage of the star's life. Again, it's about, the dying process and briefly coming back into life. Some stars flare back into life before fading to black. Perfect. Just from the title. So by defaulting to the main idea and reasoning it, we could get that right. Number 34. According to the passage, one reason the brightness of FG Sagittae has appeared to change radically from year to year is that. So why does the brightness change erratically? The star's light is periodically blocked by another stellar body. So it's good, we're talking about light, and we were talking about brightness. But the problem is that erratically means not happening consistently, or not periodically, whereas periodically means happening at, some basically set schedule. So if the star's light is periodically blocked, that would not be erratically changing. So there's no way that its brightness appears to change erratically if its light is periodically blocked by another stellar body. So there's no way that can be the answer given this question. Smoke sometimes obscures the star's light. Okay, well, sometimes that goes with erratically. It doesn't sound like there's this set sequence of when the light is obscured. And we are talking about the light, which is referring to the brightness. So this would fit with if the smoke is sometimes obscuring the star's light, that would fit with the brightness changing erratically. So this sounds actually really good. Wind is distorting the planetary nebula. There's nothing about brightness or light here necessarily, so maybe, but doesn't jump out as answering this question that well. White dwarfs don't produce visible light. Well, if white dwarfs don't produce visible light, for one, I don't know why they would be called white. Number two, if they don't produce visible light, then their brightness wouldn't change at all. It would never change erratically because it would have no light ever. The brightness would never change because there is no brightness. So this cannot be the answer as well. So we'd say it's G, and the answer actually is G. According to the passage, compared to the temperature of the core of a star undergoing nuclear fusion, so we have the temperature of the core of a star undergoing nuclear fusion, the temperature of the carbon dust from the surface of FG Sagittae is. So then we have the temperature of the carbon dust on the surface. So essentially, temperature of the core versus the temperature of the surface of FG Sagittae is. So what can we say about the temperature of the surface of FG Sagittae? It's the same as the core? I don't think so. It's slightly cooler. I would say that probably the surface is going to be cooler than the core of a star undergoing nuclear fusion, but I wouldn't say it's slightly cooler. I'd say it's probably a lot cooler. Much cooler? That sounds perfect. Much hotter? I don't know how the carbon dust on the surface could be hotter than the core. So I'd eliminate that. I'd say C sounds the most reasonable, and C is the correct answer. The passage states that when studying the wind powered by FG Sagittae, G's team used the measured amount of emitted infrared radiation to estimate the. So they're studying the wind powered by FG Sagittae, and they use the measured amount of emitted infrared radiation to estimate the likelihood of stellar material produced by FG Sagittae affecting Earth's mass. So we're talking about presumably FG Sagittae is some star, right? That's what it, even just from the other questions, that's what it sounds like. So likelihood of stellar material produced by FG Sagittae affecting Earth's mass. It's a star I've never heard of. I highly doubt that stellar material produced by this random star will be affecting Earth's mass, or even if it was, that it would be a measurable amount that it's affecting Earth's mass. So this just doesn't seem reasonable. Probability of FG Sagittae becoming a red giant by the 25th century. So, 25th century, that's a 100-year span. When we're talking about things in the cosmic scale, usually we're talking about things in hundreds of thousands of years would be usually short. Millions of years would be, still short for stars. Usually we're talking about billions of years. So the probability of FG Sagittae becoming a red giant by the 25th century seems too precise. It sounds like basically an extreme answer choice. And extreme answers are usually unlikely to be correct. So it doesn't seem like we'd be using, by studying the wind powered by that star and measuring emitted infrared radiation, that we'd be able to estimate the probability of it becoming a red giant by this in this 100-year time span. Reason for the decrease in the amount of dust generated by FG Sagittae? Well, we wouldn't really use a measured amount of something to estimate the reason for the decrease. We don't estimate the reason. Like, we could give possible reasons, but you don't estimate a reason for a decrease. So that question or that answer just doesn't pair with what the question itself is asking us for. Let's see, to estimate the amount of stellar material carried away from FG Sagittae per second. Well, yeah, wind could carry things away. So we could, by studying the wind, presumably estimate the amount of stellar material that's carried away from FG Sagittae per second. So this seems to actually, be reasonable given the question itself, and J is the correct answer. Based on the passage, FG Sagittae's efforts to restart nuclear fusion would best be characterized as. So again, this is just like really reading the question and seeing what could be reasonable, a reasonable answer to that question. So notice they didn't say FG Sagittae's ability to restart nuclear fusion. They said its efforts to restart nuclear fusion. So if we say that someone is exerting effort to do something, usually it's not easy for them to do it. They needed to exert effort. So its efforts to restart nuclear fusion would best be characterized as smooth. Usually we wouldn't associate effort with something being smooth. Something being smooth would usually be associated with being effortless, not requiring effort. Its efforts could be characterized as labored. Well, laboring to do something is very synonymous with it taking effort to do something. So labored sounds really good. Sudden, no, if we're exerting effort, usually effort is over a longer period of time, and sudden would be, instantaneous. That doesn't seem like it's efforts to restart it. Efforts also makes it sound like it's trying, maybe failing, then trying, maybe failing, not sudden. Efforts to restart nuclear fusion would best be characterized as impossible. It could have been that, except that, again, just the title of it, Not Dead Yet, a dying star is caught flaring briefly back to life. So then even just from the title, we know that it's not impossible to restart nuclear fusion. But apparently it's labored. And so we'd reason out this is the most reasonable answer to this question, and B is correct. According to the passage, G's research team used infrared light to study FG Sagittae because infrared light allowed the team to. So Infrared light allowed the team to identify the individual gases that compose the planetary nebula. I don't know, maybe. Calculate the exact number of years the star will spend in the white dwarf phase. So hopefully we're seeing this word exact number of years and saying it's probably not that. That's a very, very precise, extreme answer. And again, we're talking about things on a cosmic scale that usually take a very long time. So would we use infrared? Would infrared light allow us to calculate the exact number of years of really anything? Probably not. Using infrared light allowed the team to view the activity close to the surface of FG Sagittae. Now this seems really reasonable because we usually use light to do what? To view things. So that seems more reasonable than F, which F could have been possible, but H actually seems like it fits what we'd use light for. Infrared light allowed the team to determine the precise location of FG Sagittae. Well, again, here we have this very, very precise word. So it's an extreme answer. The precise location. I mean, what is the precise location? Is that to the millimeter? Like, what is the precise location? That would be very difficult to say that light allowed us to, find its, less than a millimeter location on this cosmic scale. So probably not that either. H is the most reasonable given the question and the answer, and it is H. At the end of the passage, the author muses that the current regeneration of FG Sagittae may eventually result in. So the current regeneration of FG Sagittae may eventually result in the formation of new life in the universe. Doesn't sound that good to me. FG Sagittae, so the current regeneration may eventually result in FG Sagittae's return to the beginning of its life cycle. I actually don't think so, just from the title, because the current regeneration should be it briefly coming back into, flaring back to life, but eventually we know just from the title that it's about it, briefly doing that but dying out, not it returning to the beginning of its life cycle. It's still dying. So no, not B. The current regeneration of FG Sagittae may result in the death of a distant star. How does that just really doesn't make sense that FG Sagittae briefly coming back into nuclear fusion or restarting nuclear fusion causing the death of a distant star? Like, those things don't seem reasonable to me. Current regeneration in FG Sagittae resulting in the onset of the red giant phase in a neighboring star. Again, I mean, I don't know how it's this one star currently flaring back in a nuclear fusion would affect the onset of the red giant phase in a neighboring star. Also, neighboring star seems really vague to me. Like, I don't know how close that is. But, I mean, maybe it's right. It doesn't seem that reasonable to me. So even though A doesn't seem great to me, these all seem, actually, B, wrong from the title. C and D don't seem really possible. So yeah, maybe it flickering back into nuclear fusion may eventually result in the formation of new life in the universe. I would pick A just because I think it's the most reasonable, and A actually is correct. According to the passage, if theoretical models are accurate, the stellar renaissance of FG Sagittae will last for a period of time best described as, well, we know that it was talking about briefly flaring, it's called flaring briefly back to life. So we know it's got to be brief, so I would eliminate billions of years. That doesn't sound brief. Approximately 100,000 years, that also doesn't really sound brief. A few hundred years, on a cosmic scale, to me, that sounds actually too short. Between 10,000 and 30,000 years, it's subjective, but I would say, to me, on a cosmic scale, 10,000 to 30,000 years, although it's really long. In human years, on a cosmic scale, that seems probably what they might define as brief. Now, actually, here, the answer is actually F, so I would have gotten this wrong, reasoning it out. But I would have gotten 8 out of 10 of these questions correct with only reading the title and using reasoning to just say, well, let's look at the question itself, let's look at the answers and see what we think could be a reasonable answer to that question. So hopefully this gives you guys some strategies and also some insights, especially into the science passages, to help you guys score higher on test day. All right, take care.